Hello, everyone. Uh, this I greet you. Um, this online science tutor. A question is brought before us is a physics question. A student bring this question, and I want to share how we can go about the solution. I just made this video to share it with you and to all students out there that are doing physics. This is a question in mechanics. Now, the question probably was asking us to find the tension and the acceleration of the system below. And of course, we are taking G as 10 meter per second square. That is acceleration due to gravity as 10 meter per second square. If it's not stated in the question, you can use 9.8 meter per second square. Now, looking at the question, how are we going to solve it? Now, when you see this type of question, the first thing that you will apply to the question is what we call the Newton second law, and which is mathematically giving us the net force. Let's say F net. That is the net force. Is equal to what? Total mass mt times acceleration. That is the statement of the Newton second law. When you have a system of masses and you want to find the acceleration, you're going to use the total mass times what? The net force is what? Total mass times what? Acceleration. This is a mathematical law of the second Newton. Mathematical statement, so to say, of the Newton second law. So I'm going to use that to solve this. First of all, let's look for the total mass, which is mt. Total mass is what? 6 plus 3 plus 2. So we have what? 6 plus 3, 9 plus 2, that is 11 kg. Good. Look, we'll keep that aside. We need it. Then let's find the net force. The net force, which is F net, is equal to the total weight force on the system. The total weight force, the net force is the differences of the total weight force. So listen now, what is the weight force of 6 kilogram? So the weight force on 6 kilogram, of course, is going to be 6 times what? Times 10, which is 6 times g. That is what? 6g. The weight force on the 2 kilogram, of course, going to 2 times 10. That is 20. That is, you can see 2g, 6 times g. So you have 6g minus 2g minus the weight force. Now, this is standing on an inclined plane. So the weight force here, of course, we don't have gravity, as in we cannot we have to resolve the force along the what? The slant, the inclined plane, because here it's not standing on a on a vertical on a vertical position. So we need to do what? We need to do what? To find the the what? The component of the what? Of the gravity, of the weight force. Now, for because there will be a reaction here, of course. And there will be a 3G, 3 times G here. And here we'll have the what? Your 30 degrees alternate angles. So to resolve this weight along this side, you have 3G cos 30. To resolve this weight along this side, you have 3G sine 30. So what you have here is that you are going to resolve along the plane. So you have 3G sine what? Sine 30 degrees. That is very good. 3G sine 30 degrees. So when you find the total net for you are going to have 6G minus 2G. That is 4G minus 3G. Sine 30 is what? Half. So you're going to have 4G minus 1.5G. 1.5G. So what you have, 4G minus 1.5, that will give me 2.5G. So therefore, the net force will be equal to what? 2.5 times 10. That give me what? 25 Newton. So therefore, our acceleration will be equal to net force over total mass. That is 25 Newton over 11 kg. So if you use we have 2 whole number 3 over 11 meter per second square. 3 over 11 meter per second square. That is actually the acceleration. The acceleration. Very important for we to actually look into it. And before we go on to the find the tension, first of all, you have to know that this tension here, let's think it to be what? T1. Of course, the object is going to move in this direction. Acceleration. So the object here is what? T1. This is T2. So there are two tension because we are having two pulley. So I will for we to find the tension, I will like you to digest this one that we just find now, the acceleration. Look at it. If there's anything that you don't understand in it, you can give a comment in the section. Then I will explain the more. Then we can find our tension. How should we find our tension? For the T1, now very simple. Look at the way I usually solve this is that when you look at 6 kilogram, 3 kilogram, 2 kilogram, which one is bigger? It's 6 kilogram. So this kilogram is pulling it towards this what direction. So for the T1, since it require an extra push, you get what I'm saying now. So it's going to be 2 times 2G plus 2A, because you are assigning extra push going upward, pushing it upward. So you have 2 times 10, that is 20, plus 2 times 25 over 11. There's our acceleration, you remember? So you are going to have 20 plus 50 over 11. So if you are able to calculate this, that will give us 270, because when you find the SCM, that will give us 11 times 20, that is 220, plus 50, that is 270 over 11 Newton. That is our T1. Then we can look for our T2. We are going to look at it. Since the weight is coming, the object is moving in the direction coming down, so it requires less tension to come down. So we're going to have 6G minus 6A. So it's going to give us 6 times 10, that is 60 minus 6 times 25 over 11. That gives me 60 minus 25 times 6. 25 times 6 will give you 150 over 11. So if you find the SCM, so you're going to have 660 minus 150 over 11. So that will give me 0, 1, 510 over 11 Newton. 510 over 11 Newton. So your T1 is what? 270 11 Newton. Your T2 is 510 over 11 Newton. Then your acceleration is what? 3 over 11 meter per second square. So if you have solved this question, or you are a physics student, you can also resolve the question and see whether um, you are correct. To see a similar question like this, please subscribe to my YouTube channel. Subscribe to the YouTube channel, and anytime I drop question that like in this manner, you will be the first person to actually see them. That is the solution for the question brought to me by a student. I hope you have been able to see and gain from this video. Once again, I remain your online assignment tutor. Bye for now. I will see you in the next video. Ciao, ciao. Bye bye.